White balance. It's fundamental to making good quality images and seemingly pretty simple when you look at it on the camera. But what goes on under the hood is somewhat more complicated than you might actually expect. What's up everybody, I'm Jason and welcome back to some more tips and tricks for the Canon EOS R5. So this video is going to kick off a series of videos looking at how to white balance your camera, your photos and videos on the R5, what the camera can do, the whole kind of ins and outs on that process. So this video we're not going to get into doing some mechanics, the mechanics of the camera. We're going to be talking about white balance on the R5 in a bigger picture in terms of capabilities. Now, pretty much everything I'm going to be talking about in this video, with the exception of maybe the tests that I'm going to talk very specifically about, applies to pretty much all of Canon's other current production cameras. What we're going to be talking about here are the general capabilities, what are the modes that Canon uses or has, the iconography that describes those modes, that kind of thing, the color temperatures that modes and the white balance system operates within, and the intricacies of what goes on with auto white balance and with flash white balance. Before I start talking about the details of this, I have a tiny little rant about the way Canon does things on their cameras. So throughout the user interface, Canon identifies the white balance mode that you're working in by an icon. This applies to when you're setting it in the menus, and this is the problematic part also when you are looking at the color temperature that or the image review information in your shot. So there is no way to get the camera to tell you actual color temperature information. It will only tell you the white balance mode you're in. So if you shoot something in, say, auto white balance, and then you want to set those transfer those settings to another camera, you don't have any way to do that without pulling the image off the camera into a computer where you can actually look at what color temperature is involved. So that mini rant out of the way, let's talk about what's going on the EOS series cameras. So there are currently 10 different white balance modes available on these cameras, and these are split between preset and customizable options. So there are 2 auto white balance modes. This goes all the way back to 2016. Anything prior to that will only have 1. There are 5 preset color temperatures. These cannot be edited. They correspond to a single color temperature, so like daylight or tungsten. There is a flash preset mode, which is more complicated than just being a preset color temperature. There's actually processing that goes on in the cameras. We'll talk about this in some detail at the end or towards the end of this video as well. And of course, there are 2 custom modes. So these are the options that we have to set the white balance however we want on the camera. So we'll start with the preset modes because these are really easy to wrap your head around. Basically, you have 5 modes. They correspond to a color temperature that is preset. You can't do anything with it. So these are daylight, which is 5200 Kelvin, shade, which is 7000 Kelvin, cloudy, twilight, and sunset, which is 6000 Kelvin, tungsten, which is your standard 3200 Kelvin, and white fluorescent, which is 4000 Kelvin. Now, bear in mind, these also, in addition to having a color temperature, also have the appropriate green magenta corrections built into the setting. So that's the the preset modes. Next thing I want to talk about quickly are the custom modes. Now, the reason I'm talking about these here and not getting into a whole bunch of detail is I will have videos talking about these in a lot more detail, how to actually go about using them. I just want to talk about sort of the big picture, what they do. So the 2 custom modes are custom and color temperature. Both of these modes allow you to set a color temperature on the camera between 2500 and 10,000 Kelvin. In color temperature mode, you can do that in 100 Kelvin increments, but in that range. In custom mode, you do this by taking a picture of a white reference target, such as the color ref or the white card that's over here, and that camera, knowing that that reference target is supposed to be white, will go about making all the adjustments to both the color temperature and the green magenta correction that is necessary. Now, one thing to be aware of in the color temp mode, if you are working with fluorescent lights in the environment that you're in, the color temp mode does not have a baked-in correction for that green light. So that brings me to auto white balance. Now, of course, auto white balance is easy mode, you could call it. You put the camera in auto white balance, you take pictures, the camera does its thing to figure out what you need the white balance to be, and you don't generally have to worry about it. In fact, In all of the years that I've been doing photography, I almost always use auto white balance because it gets the image good enough out of the camera. And of course, if you're shooting raw, you can make any corrections you need to make in post without having any loss of image quality. So auto white balance on the R5 and its siblings has a working range of 3,000 to 7,000 Kelvin. So that's pretty much covers the light situation that you're generally going to run into. Almost. The only real exception to this is that there are a lot of warm white LEDs, warm white fluorescents, and even certain tungsten lights that might be found in a residential setting that are more like 30 or 2800 Kelvin. So doesn't quite get down all the way to that end. However, we'll talk about in the testing, this is actually surprising, can be surprisingly good in that situation, even though it's outside of the design parameters. Now, modern Canon cameras, anything from the newer than the EOS 1DX Mark II or 5D Mark IV, will have two auto white balance modes. These are ambience priority, which is the default auto white balance mode, and it's indicated on the camera by just the AWB icon, and white priority, which is a new mode that attempts to completely eliminate or completely neutralize color casts. So white priority is indicated by the AWB W icon. And that's really the difference between ambience priority and white priority. Ambience priority, as the color temperatures drop as you get closer to tungsten, tries to retain a certain amount of ambience, a certain amount of that warmth in the resulting images, while white priority strives to eliminate that. So I wanted to see how all of this worked. So I put together a test process for this using my Calibrite white balance card and an Aperture Amran P60C RGB LED light. So lit the card with the P60C and then made a series of images off of that with different lighting or color temperature lighting, watching what the auto white balance does. So I ended up shooting at 21 different test points, different color temperatures from 2600 Kelvin to 7500 Kelvin in approximately 12 myred increments. And at each test point, I shot between 2 and 4 images. So I shot an auto white balance and an auto white balance white priority image at all 21 test points. From 4500 Kelvin and below, so from 2600 to 4500 Kelvin, I also added 0.5 green color cast to the lighting situation and shot an auto white balance and auto white balance white priority image there as well. So what I found was actually pretty interesting. So starting out at the top of the test where I actually did start 7,500 Kelvin, working down towards 5,000 Kelvin, I found ambience and white priority were basically the same. Both of them were pretty neutral, or very neutral, I should say, but you did start to see ambience priorities adjustments starting to kick in a little bit, I think, towards the 5,000 Kelvin end of this test. So by 5,000 or at around 5,000 Kelvin, the ambience priority images was ever so slightly warmer than the white priority image. Now, in practice, the difference is irrelevant. You're never going to see it if you just take a picture and go about with your life. The only reason I noticed the difference is that I had these test images side by side, so I could toggle back and forth very quickly between ambience and white priority, and you could just start to see the slightest difference starting to crop in at about 5,000 Kelvin. So stepping into the next range where the camera did stuff was about 5,000 Kelvin to about 3,500 Kelvin. Now, this is the range where you're going to run into fluorescent lighting situations. And that's pretty much the thing that came out of all the testing here. So by 4,800 Kelvin or so, ambience priority really, without any kind of color cast in the light, so just straight color temperature, ambience priority really started to kick off and become warm. Again, 4,800 Kelvin was still pretty immaterial or pretty minimal in terms of its difference from white priority, but definitely noticeable in side-by-side images or if you were growing through a group of images that were shot in the two modes. Not enough that I would say that you have to shoot in white priority to get neutral images or anything like that. Pretty close. However, when we hit 4500 Kelvin, and specifically the range 4500 Kelvin to 3500 Kelvin, ambience priority picked up on being warm pretty immediately. Like, it just jumped into, gradually, it wasn't a like immediate thing, but jumped into having that strong or that warmer cast. On top of that, white priority also had a slightly warm cast. So neither of these worked really perfectly spot on in this range, but white priority was very close to being neutral, just slightly warmer than I was seeing at the higher color temperatures or will see in the lower color temperatures. Now that said, if I introduced, or when I introduced green light into the test situation, both ambient priority and white priority snapped to being very neutral. So ignoring the like ambient side of things, both of these got very, very neutral, very whites. I think what this is demonstrating is that Canon has, in the process of writing their, or, developing their auto white balance algorithm, has a fluorescent lamp or fluorescent light optimization going on. So as I said, 4000 Kelvin plus or minus about 500 Kelvin, so the 3500 to 4500 Kelvin range is a range that is really dominated by fluorescent lights in practical situations. Generally speaking, commercial, residential, that kind of, non-photo or video LEDs tend to either be really warm, so they're the 2800 to maybe 3500 Kelvin range, or they tend to be really cool, so 5500, 6000, 8000, even 10,000 Kelvin in some daylight, quote, daylight LEDs. Likewise, in practice, out in the real world, that 3500 to 4500 Kelvin range is not really something you're going to see from, say, the sun. So the optimization seems pretty safe. If you're concerned and you're not going to be doing white balance adjustments in post, you might want to use white priority, which is going to do a better job in that color temperature range of neutralizing any casts. That said, in both situations, the green cast was completely removed. So in fact, in all of the tests that I did where I introduced green to the light, the camera did remove the green and produce an image that was at least not colored with a green or magenta cast, or at least a noticeable one. So that brings me to the bottom end of the range. The 3500 to 2600 Kelvin range are part of the test range. And obviously, from 3000 to 2600 Kelvin, we are working outside of the Canon designed test or capabilities. I wanted to see how this was again, or worked again, because warm white LEDs fall in that 2800 2900 Kelvin color temperature range, and that's, like I said, slightly outside what the camera supports, but you're still potentially going to run into those in practical situations. So when the camera was in ambience priority, the situation was that the images tended to be pretty warm. In white priority, again, right after I dropped out of that 3500 to 4500 Kelvin range, things snapped back to being really neutral without having to worry about a green cast in the lights. What was really impressive to me, though, is that white priority maintained white balance neutrality, or maintained proper white balance or near proper white balance below the camera's designed white balance range. So I saw color temperatures being set by the camera as low as 2900 Kelvin. So that's outside or below the 300 or 3000 Kelvin range that the camera is supposed to be working in. And white priority did a reasonably good job, at least at 2800, 2900, and even to a certain extent 2700 Kelvin, of producing a pretty neutral looking image. So if you are working in those environments and you do want to use auto white balance and you do want a fairly neutral image, or at least a minimally ambient tinted image, try white priority instead of ambience priority for that. Now, the other situation with flashes or with white balance comes down to flashes. Canon's flash situation in this respect is a little confusing from the start, so I'm going to have to start there. Broadly speaking, Canon flashes can be lumped into 3 different categories. So the first category are flashes that do not provide any color correction information to the camera. So this is going to be anything older than the 580EX or released prior to about 2004. Additionally, this likely applies to third-party flashes, at least in the specs that I've read for stuff from Yongnuo or Godox. I have not seen anything in their specifications that says those flashes provide color temperature information. Unfortunately, I don't have any of those flashes to test with. That said, if you do have one of those flashes and you have seen color temperature shifts from it, leave a comment below and let us know so that we can, all learn something here. Now, starting in 2004 with the 580EX, Canon wanted to bring up their flash and color balance game a little bit, so they added the capability for the flash to provide color temperature correction information through the ETTL2 connection. And it provides that information for the camera to do with in the processing of its white balance settings. Now, Canon improved or expanded upon this starting in 2012, at least for their highest-end flashes. So this would be the 600EX RT, the RT Mark II, and the current flagship flash, the EL1, where the camera or the flash can determine if there is a color correction gel mounted to the front of the flash, and if so, it provides that information to the camera as well. Now, again, what is done with this in terms of white balance is going to depend on the mode that's on your camera. So for auto white balance users, if you are shooting with a flash, the big thing that you have to be aware of is you essentially lose white priority. White priority on the Canon cameras when a flash is mounted operates as ambience priority, so just straight auto white balance. At least that's what Canon says in their documentation. What I've seen in testing is that the 2 white balance modes definitely seem to appear to operate the same way, but ambience priority tends to not include as much ambience. So things tend to be cooler or more corrected in terms of white balance. In any event, while I did notice that the 2 flash modes work basically the same from a color perspective, I found that white priority consistently drove the flash at a higher output power than I was seeing in ambience priority. This was not a huge change. It didn't change the exposure or anything like that, but I could definitely see in the fringe areas of the scene, which were only being illuminated by the flash in my mixed light testing, that they had somewhat more or a somewhat higher exposure, indicating that the flash was producing more light into the scene. I don't know, again, if this is just a quirk of the test setup that I was doing or is a design thing in the way ambience and white priority actually organize the flash output, but this was consistent across several test rounds, like 7 or 10 different tests. Now, as far as the color and auto white balance goes, auto white balance, when you're using a flash, still does the auto white balance calculations. So in a mixed light scenario, you will end up with potentially a white balance that's halfway between the flash's white balance and the scene ambient light white balance. Now, flash white balance mode is a lot simpler, but it still does things based on a decision matrix. So if the flash does not provide any color temperature information to the camera, the flash or the camera simply sets the white balance to 6000 Kelvin. If the flash does provide color temperature information to the camera, whether it's just the small correction information that most Canon flashes will provide, or it's the full gel correction information of the flagship flashes, the camera will adjust the color temperature based on that information. So if you have a color temperature orange gel on your 600EX, you will get an image that is gel or that was balanced for that color temperature, even if that's not what it's supposed to be. Now, the last thing I want to cover in this video talking about white balance and the big picture on Canon's EOS R5 and its siblings is what happens in movie mode. So movie mode, by and large, works the same way as the still mode does in terms of the white balance options and settings and how things work. There are a couple of differences. For example, flash is not available in movie mode because you can't shoot with a flash when you're shooting video. The second difference is that you cannot change the white balance mode while recording. Well, I guess technically you can't change the white balance mode in the middle of shooting a picture in still mode either. So you can't change the white balance mode while recording. This means that if you are set to, say, tungsten and you're going to walk outside, you will need to stop recording, change the white balance to daylight, and start recording again. You can't have the camera, or you can't just set it on the camera or change it on the camera and have it do its thing. The only exception to that is, of course, auto white balance. Auto white balance will change the white balance in response to the scene's lighting anytime the camera is working. However, there are a couple caveats to this. First of all, it takes approximately 30 seconds for the camera to change white balances, at least in fairly extreme cases. So in testing, I went from 5600 Kelvin to 3200 Kelvin and back, and it would take 30 seconds to make that transition. So 5600 to 3200 Kelvin, the camera took 30 seconds before it stabilized on the new color temperature. Now, unfortunately, this also doesn't have, or the camera also doesn't provide an option to change the update speed. Further, this happens whether you are in standby mode or recording mode. So unlike something like the Movie Servo AF, where you can make the camera focus quickly in standby mode and focus real slowly in movie mode, when you are shooting with the auto white balance, it's always going to be at the same rate, and it's the standard rate across the two. Now, this does mean that if you're in standby mode and your lighting changes dramatically and you need to get the white balance to switch over, it's going to either take time to do it and you're going to just have to wait, or you can, I found a reasonable workaround for this delay, which is simply switch the camera out of auto white balance into, for example, daylight, and then back into auto white balance. When the camera switches into auto white balance, it redoes the white balance calculations and sets that white balance without any delay. So that is the big picture situation with white balancing on Canon's cameras. In future videos, we're going to be talking about the mechanics of changing the white balance, seeing where the white balance settings are, and ultimately how to go about setting the white balance if you are on your camera in a variety of ways. So I hope you found this useful or at least interesting. If you did, let me know by hitting that like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. Finally, if you'd like to directly support this channel and future videos like this, please consider hitting that thanks button down below the video. And as always, thanks for watching, and I'll see you next time.